ladies and gentlemen. Hasn't been very long, but that's okay. This one won't be very long either. Last time we talked about how different kinds of chemical reactions have a grouping, a category, a family that they belong to. They behave in a certain way that is very similar, right? Like decomposition reactions always have one complicated thing turning into two smaller things. A single displacement reaction always has one dance partner alone, but it's a different dance partner on both sides of the equation. Synthesis takes two and becomes one. Combustion has got these careful hallmarks that are always there. But that's the thing. These are predictable. Yeah. We can use this knowledge to identify what will happen based on the starting conditions. And this is incredibly powerful because there are literal billions upon billions of chemicals out there. But now we actually have the ability to know what's going to happen before we do the experiment, which can be useful because like a combustion reaction, as we just said, burns things. You don't want to have to find out the hard way. If I mix these two things together, does it explode? That's apparently how they figured out gunpowder. They originally thought it was going to be medicine. Whoops. So what's an example? Well, there's my example. What's that going to do? Whoa, that's a lot to go on, right? Like immediately, it's just two things. That's it. Oh, it's two things. All right, already we have an idea. It's two things, so it's not going to be decomposition. It can't be. Decomposition starts with one and breaks into two. Do I have any multiple dance partners here? No, each one of these guys is alone, right? The aluminum's by itself, the chlorine's by itself. Well, by itself, covalent. There's no carbon, there's no oxygen, so it can't be combustion. It can't be single or double displacement, and it can't be decomposition. Well, it has to be synthesis. Right? Because that's the only thing that'll make sense. So if this is synthesis, then I know that the aluminum and the chlorine will come together. Now, of course, I need to make sure to balance this properly. I need to understand that the aluminum is going to be 3 plus because it's in the third family, and the chlorine is 1 minus. So I need to make sure that I put a 3 down here. But if I do that, I think I'm done, right? Like, I have predicted the product. You now know what will happen if you put these two things together, and you didn't actually have to do it, which is for the best. Chlorine gas is pretty dangerous stuff. Aluminum, well, not so much. So, I mean, we're not fully done. We could balance this equation, right? Like we could look at this and go, oh, there's a 3 here, there's a 2 here. So I could toss a couple balancing marks in here. We could go 2, this should be a 3, and this should be a 2. That'll finish it off for sure, but you know, that's secondary. Let's try a couple others. What happens if I give you this one? That's it. Nothing else. Okay, well, this one should be even easier than the last one. We literally have one thing. I can't switch dance partners. I'm not burning anything. I'm certainly not combining it. It has to be decomposition. I'm starting with one complicated thing, and I don't have anything else. So the only thing that makes sense is for it to break down. So I'm probably going to get some aluminum plus some fluorine. Oh, but fluorine is a diatomic, right? So it'll share because it has no choice. So if I look at that, that has to be decomposition. And it makes sense that I should balance it. So like, this is going to be a 3, which means this is a 2 out front, which means I got to put a 2 there. All right, there we go. That wasn't so bad. We're looking for all those distinguishing features, right? In the last video, we discussed how the different chemical reaction types have different features, properties that are similar, connected, relating all of them. But now, because of that, we can identify the features in a new problem and then go, well, we know what's going to happen, right? Similar to the sense of somebody sees you, they can vaguely guess on who your parents might be. And they can be, oh, yeah, okay, you look kind of like your dad or your mom, right? You may have heard that before. It's the same idea. So we do another one. Li plus CaO. All right. Well, we're kind of going down the list here, so it's probably not a single displacement. Oh, actually, it is a single displacement. I just gave it away. Why is it a single displacement? I'll take a good look at it, right? I got one complicated guy and one guy by himself. So these two dance partners are going to switch. Why these two? Because these two are the metals, right? It's not going to be the oxygen and the lithium switching. That's not going to work. So if I switch out the metals, that means I'm going to get LiO plus Ca. Now, of course, I got to get the charges right, so this is going to be Li2O. Now, I could always balance it. You know, there's two lithiums. Oh, well, that's actually really easy to balance. I just throw 2 in front. We're looking for the distinguishing features. We're putting them together. Next one. Mg. Cl2 plus Li2O. All right. Obviously, this one is a double displacement. And just as obviously, we're going to swap two. We can swap any two. You know what? We're going to swap the two nonmetals. We swapped the metals last time. We're going to swap the nonmetals. It doesn't really matter at the end of the day so long as they switch dance partners. If we do that, we're going to get MgO plus LiCl. In terms of the balance, toss a 2 in front there, and I'm done. With this ability, with this knowledge, we can now predict what will happen with a pretty good degree of accuracy. Now, these categories are made by people, so not every chemical under the sun is going to balance into these, or is going to fit in all of these 5 categories. I did say that there were going to be 6 that we're going to learn about, but not right away. Well, there are more than 6 categories of chemicals. But for the now, you guys can work with this. You can begin from here. One last one. Obviously, we got to finish it off. C5H12 plus O2 is going to make, well, we should know. I mean, we've literally gone through all the others. This must be combustion, which means we're going to get CO2 plus H2O. What's the balance on that one? I'm going to leave that for you. I've been doing all the rest of them. Admittedly, I'm leaving you the hardest one, but yeah, well, you know, it's only fair. I did more, you do the harder one. It's like fair. It's like fair. That's it. That's basically what we're dealing with here, guys. And the key thing, of course, is that we're going to use the features of each reaction to identify and predict the products. This is the power of patterns. When you spot the pattern, everything becomes a lot easier. You don't have to memorize all of these formulas. There's literally billions. You memorize the idea, and then you apply it, and then you're done. I'm about done myself. So this will be a really short one. Once somebody gets this video, they're going to be like, Mr. C, what happened? How did you talk for so little time? But that's okay. Can't always chat forever. Spend some time practicing, and I will see you guys next time.